Welcome to the world of Robert Sorby. In this video we will be looking at the fundamentals of woodturning. Woodturning is an exciting and dynamic way of creating objects of beauty and function. It can, however, be a world full of jargon and mystique. In this video we will try to unravel this world by looking at wood selection and some common faults to look out for, the lathe, methods of holding the wood so we can work it, tool selection, usage and sharpening. We shall also use these tools to create a few simple projects. These include a weed pot or bud vase, a goblet and a simple bowl. And finally we shall look at how to finish them. Let's take a look at the first of these topics, wood. This is a daunting subject to novice and more experienced turners alike. What wood do I use? How do I buy it? What do I look for? All of these are subjective questions and we shall try to answer them as we go along. To that end, let's go and have a look at a typical wood store to see what we can find. It is worthwhile to find a local wood supplier and get to know them. They often have a good selection of wood and can be a wealthy source of information. On first entering a wood store, the selection of woods can be quite overwhelming. Do not worry. There are many species and subspecies of wood available, and all of them have different turning characteristics and colour. This is one of the things that makes turning the dynamic craft it is. There are basically three ways to buy wood. One is boards or planks, another is logs or branches, and the last is pre-prepared turning sections known as blanks. Let's have a look at the first of these, boards. This is a typical board. You can see that the sides are wavy edged and still have the bark on. This is because the tree has been felled and then cut longitudinally. This type of board is referred to as through and through section. This is one of the cheapest ways to buy wood, but it has its pitfalls. One is the need to cut the wood to size. The most common method of doing this is with a bandsaw. These come in all shapes and sizes and can handle different sizes of board. Boards often have defects, for example end splits, which are caused by the wood drying. It may be warped, which means that any section from this area will be a strange shape. There may be some bark inclusion, which will probably fall out whilst turning, leaving a hole. These defects are things to look for, but are not the whole picture. Sapwood is the part of the tree that conducts the sap or food to the leaves. It is usually a lighter colour than the heartwood, and in some cases can make for stunning contrast between the two, as with this yew. Heartwood was once sapwood, but as the tree grows, any new growth becomes the sapwood, and the inner sections become harder and become the structural support for the tree. There are benefits in buying boards. The price is lower than pre-prepared sections, and it allows us total freedom as to the size of piece to cut. We can often work round those defects mentioned earlier. It is also possible to choose a specific area to cut the piece from. This allows us to make the most of the grain. The word grain is used to describe the structure and pattern of the growth of the tree. This is shown clearly with this piece of ash. The bands are spring and winter growth. In the spring the tree grows a lot, so there are big bands. The bands narrow off as the growth slows down towards autumn and finally stops in winter. These narrow bands are often darker and harder than the summer growth. All trees have different colours and figure. The word figure denotes pattern. This chunk of wood is known as a burr or burl. These are often carbuncle type structures which are prized because they may have a beautiful figure inside, as with this burr elm. Note the tight cluster of dots and whorls. These are knots. This burr elm is radically different to this normal piece of elm. Woods that have a lot of figure can be expensive to buy and hence are not recommended for the beginner. A piece this big will either be used to produce a large bowl or be cut into sections known as slabs. Slabbing is an economical method of working with wood of this quality, as many pieces can be produced from the slabs. Another method of obtaining wood is as a branch or log. This type of section is known as in the round. All different shapes and sizes can be obtained. The sapwood and heartwood contrast well on this laburnum log. The end grain of this yew branch has been sealed. The log has had the end cut off and exposes the end of the fibres, hence the name end grain. This has been sealed with molten paraffin wax to reduce the chance of the wood splitting. Splitting is caused by moisture loss. Simply put, sapwood and heartwood dry at different rates. The sapwood dries more quickly than the heartwood, so stresses are built up, resulting in the wood splitting. Moisture is lost the quickest through end grain. By sealing it, we can slow the drying process down. Wood is best stored under cover, in a cool place, out of direct sunlight and with a good circulation of air. If this is the primary method of drying the wood, this is known as having been air dried. Wood that has been kiln dried can also be obtained. Kiln drying is where the moisture content has been reduced under very controlled conditions in a kiln to a level where the wood will be stable and unlikely to warp or split. Whichever method is used, wood is a living, breathing material that reacts to the ambient climate. The other way to obtain wood is to buy ready prepared blanks. There are two types of blank. One is known as discs, which are used to make bowls and platters. The other is known as square stock, which is lengths of wood suitable for spindle work. Blanks are often the most expensive way to buy wood. However, the wood is cut to a usable size, end sealed, often kiln dried. The grain is also clearly visible. In many ways, for the beginner, this is the simplest method of buying wood. Before we can use the wood, we need a lathe to work with. The lathe is a machine that rotates the wood at speed so the turner can profile it to a specific design. During this process there can be considerable forces generated. So it is very important that the lathe be of a good, robust construction. The best material for a lathe is cast iron, which is heavy and dampens any vibration well. Vibration will take a lot of the pleasure out of turning. Ideally, the lathe should be able to turn up to a 10-inch diameter bowl. Because there will be different sizes of wood turned on the lathe, a minimum 4 speeds between 400 and 2000 RPM is recommended. The lower speeds will cater for large diameter work, and higher speeds the smaller diameter work. It should also have a good, rigid stand to support it. A lathe will consist of a headstock, which is the main working end of the lathe. This one features a swivelling head, which means that the headstock can be rotated to access any work fully. And if the urge takes us, we can turn big work with the aid of a large bowl turning attachment. The headstock houses a threaded spindle, to which various accessories can be attached to hold the wood when turning. Inside there is a series of stepped pulleys which are driven round by a motor and a belt. The speed that the spindle rotates is governed by the pulley that the belt is on. By moving the belt to a different pulley, we change the speed. We will look at speeds for turning later on in this video. On more expensive lathes, there can be a variable speed motor fitted. The benefit of this is that we do not need to change the pulleys to change the speed. Instead, the speed of the lathe can be controlled electronically at the turn of a dial. This will give an infinitely variable range of speeds within a defined band, for example 0 to 3000 RPM. The headstock is connected to a lathe bed of some sort. In this instance, the bed consists of round, solid, hard-chromed bars. The lathe bars act as a carrier for a tool rest assembly, which is also made from cast iron. Into this assembly can be fitted a tool rest. This is the working platform or fulcrum point for the tools. At the other end of the lathe there is a tailstock. By rotating the hand wheel, the quill is advanced or withdrawn. Into this can be fitted various attachments. This is the unit that stabilizes the unsupported end of long pieces of wood for turning. In addition to these features, the lathe should have a well-constructed stand to support it. To work safely, the lathe needs to be set up to suit our height. This can be worked out by standing by the side of the headstock with our arms by our side. The centre of the spindle should be about elbow height. This height will afford us optimum tool control and keep us upright when working at the lathe. Good lighting is essential when turning. This can be from a window or strip lighting. There are basically two styles of turning. One is called between centre work or spindle turning. This is where the grain of the wood runs parallel to the axis of the lathe bed. Traditionally, this type of work is held between a drive centre or spur. There is a taper on the spur, which is known as a Morse taper. This fits into the headstock spindle, which has an exact opposite taper, allowing it to fit perfectly without slipping. And a revolving centre. The revolving centre revolves on a set of bearings, hence the name. This fits into the tailstock by means of a Morse taper. The wood is then held centrally between the two. Note the tailstock is locked just before the revolving centre touches the wood. The handle is then turned, which causes the quill to extend and force the centre to hold the wood in position. These support the wood as it rotates. Here are some examples of spindle work. You can see that the grain runs along the length of the work. The other style of turning is faceplate work. The grain in this type of turning runs at 90 degrees to the axis of the lathe bed. For this we use discs of wood cut from planks or boards, which can be held on the lathe with a variety of methods. The first of which is a faceplate. A faceplate is a machined metal disc that has a series of holes in it through which screws can be fixed to the wood. This is screwed onto the wood centrally. To find the centre of a piece of wood we can use a centre finder. This is placed against the edge of the wood. There is a cutaway section in which there is a strike line. If we draw along this and then move it and repeat this process, we end up with an intersection point. This is the centre of the blank. Align the faceplate with the centre and fix with screws. When the wood is secured, the faceplate is then screwed onto the spindle. This is a very secure method of holding the wood, but it is time consuming. An alternative method is to use a screw chuck, which relies on a screw held in a metal plate to secure the wood to it. This one has screw holes in, should a more secure hold be necessary. A pilot hole is drilled in the centre of the disc the size of the solid section of the screw. This will allow the thread of the screw to bite into the wood and hold it. The wood is then screwed onto the screw chuck. Another method is to use a chuck. There should be a good selection of jaws to hold a wide variety of sizes of project. The chuck jaws can contract and lock onto a spigot, which is a little bit like a tenon with dovetailed sides for the jaws to grip onto. It can also expand and lock into a recess. This also has a dovetail undercut section for the jaws to hold onto. The more advanced chucking systems can hold screws, so act as a screw chuck, and drive spurs to hold spindle work. Here are some examples of faceplate turning. Note how the grain runs across the work. Having looked at the topic of wood, the lathe and its components, and methods of holding projects, we are now in a position to look at the tools that we use to profile the wood. Primarily, tools are divided into four main groups: gouges, skew chisels, parting tools, and scrapers. All of these are used to shape the wood, but each group has a specific function. Let's look at gouges. A gouge consists of the following: a blade. Ideally, all blades should be made from high-speed steel. It is more resistant to the abrasive qualities of wood and the heat generated by friction during turning than a blade made from carbon steel. A flute, which defines the profile of the cutting edge and how it is used. A bevel, which is the control point of the cutting edge. A cutting edge. An edge is an intersecting line between two adjoining faces. Because we cannot see the edge, I've coloured it green. On a gouge, it is the intersection between the flute and the bevel. A tang, which is the section of the blade that fits into the handle. A ferrule, which prevents the handle from splitting when the blade is inserted in the handle. And finally, a handle. This serves two vital functions. One is balance, and the other is control. Blades are different lengths, so different sizes of handle are fitted to ensure the optimum ratio of balance and control. There are three types of gouges to look at: roughing gouges, bowl gouges, also known as deep flute gouges, and spindle gouges, which can be called shallow flute gouges. The first in this group is the roughing gouge. The roughing gouge is used to profile spindle stock down to round from square or uneven branches. It has a large, wide flute and has a cutting edge which is ground square across with a bevel angle of 45 degrees. To use it, we need some wood. Maple and sycamore are ideal woods on which to practice the techniques shown in this video. If these are unobtainable, fruit woods like cherry or apple can be used. Remember, for between centre work, the grain runs along the length of the lathe. Here is a piece of sycamore square stock held between centres on the lathe. The wood is 3 inches by 3 inches square and 12 inches long. The tool rest should be positioned just below centre and as close to the wood as possible without fouling it when the wood is rotated. There should also be an overhang past the end of the wood. The rest should always be as close to the work as possible. However, do not adjust the rest unless the work is stationary. Before we use the roughing gouge, we will look at some safety equipment for turning. To protect your eyes from chips, we need some safety glasses. These have impact resistant lenses, so will protect the eyes. The dust produced when turning can be hazardous. We could use a small disposable mask to protect our lungs. A better option is to use a personal respirator, which will provide full face and lung protection. The air is drawn through filters in the head unit, and the filtered air is passed over the face. Another option is to use a portable extraction system to remove the fine particles of dust. This can be placed close to where the dust is produced. The air is filtered when drawn into the system and then exhausted out, devoid of the fine dust. Another important aspect when turning is balance. Our balance is affected by how we stand. A good stance for turning is to stand about 12 inches back from the lathe and have the left foot pointing towards the lathe and the right foot back and pointing at an angle of 45 degrees. This allows us to shift the balance from one foot to the other when cutting without having to shuffle along. We can now use the roughing gouge. The gouge is positioned on the rest and a hand is placed over the blade or holds it from underneath to stabilize and control it. The other hand holds the handle. This is used to control the cutting edge. The flute always points in the direction of travel. If we move the tool towards the right, the flute points to the right. Reverse the positions when moving towards the left. Start the lathe up to 800 RPM. This is a good speed to rough down this diameter of wood. A good rule of thumb is, the bigger the work, the slower the speed that it should be turned at. Once the lathe is running, place the tool on the rest, present the tool to the wood so that the heel of the bevel, the area coloured green, is rubbing against the wood. A distinct tick 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 will be heard. Raise the handle until the cutting edge starts to cut. Push the tool forward along the wood with the flute pointing in the direction of travel. The part of the blade that is in contact with the tool rest is directly in line with the section of the cutting edge that is in contact with the wood. If the flute is pointing in the direction of travel, the cutting will occur on the lower wing of the flute. Make a series of small cuts taking the wood from square to round. The term to rough down is where this particular tool gets its name. The wood is roughed down or made round. Gradually work backwards until we are about 3 inches from the other end. Note, as the tool cuts, the bevel behind the cutting edge rubs on the wood. This is called rubbing the bevel. Remember, the bevel controls the cutting edge, so we have to maintain constant bevel contact with the wood when cutting. There is a golden rule when cutting wood. When cutting, there should always be a longer fibre supporting the one being cut. In general terms, this means always cut downhill. If we cut uphill, we end up with a very rough finish. This is because the fibres pluck out through lack of support. When we cut downhill, it leaves a smooth finish because the fibres being severed had support from longer ones in front. Here is a diagram to illustrate cutting downhill when roughing down a cylinder. We are now going to cut in the other direction to rough down the last section of wood. Note, we are cutting downhill with the flute pointing in the direction of travel. Make a series of cuts to round off the remaining square spindle stock. Let's stop the lathe to see how we are progressing. We're not quite there yet. A few more cuts and it will be round, but before we make the final cuts, let's look at how we sharpen the roughing gouge. There are fundamentally two types of sharpening method. One is called dry grinding. Typically this will involve a bench grinder. A bench grinder has wheels that revolve at speed, and a tool is placed against these to sharpen it. The wheels on this bench grinder are made from aluminium oxide. A good grade of wheel for sharpening tools is 80 grit, and for profiling or shaping tools a coarser 36 grit wheel is recommended. When buying an abrasive wheel, the higher the grit number, the finer the wheel. The angle on this roughing gouge is 45 degrees. The grinding angles that are mentioned for tools are a recommended starting point. As a turner's skill develops, these angles can be altered to suit a given situation. An adjustable rest will assist us when grinding by providing a stable platform on which to work. This one has the degree settings marked on the stem, so we can adjust and lock the stem at a given position and know that the angle is correct. When the rest is adjusted to the correct angle, switch the grinder on. Lay the blade flat on the grinding platform and rotate the bevel gently against the wheel. The spark shields which were fitted on this grinder have been removed so as not to obscure the filming. Tools should be sharpened frequently to maintain a sharp cutting edge. If the edge is dull, the tool will not cut and a good surface finish is impossible to achieve. A continuous single bevel without facets is what we're looking for after sharpening. The wheels will need to be cleaned every once in a while to ensure they cut properly. Note the grey marks on the stone. This is embedded metal which we need to remove. This process is called dressing the wheel, and it is done with the devil stone which is rubbed across the face of the wheel. The wheel is now clean and ready for use. The other style of grinding is called wet grinding. As the name implies, water is used as a lubricant. This machine has an aluminium oxide wheel running at slow speed in water. The water cools the cutting edge as it grinds the tool. The principal method of sharpening the roughing gouge with this system is the same. The gouge rests on a platform and the blade is rotated whilst the cutting edge is in contact with the revolving wheel. A facetless bevel is still the required end result. When the gouge is sharp, we can make a few final smoothing cuts on the wood. To do this, start the lathe up to about 1800 RPM. We can increase the speed at this point because the diameter of the work is smaller. Angle the flute in the direction of cut and traverse the gouge across the surface of the wood. Note how the wood peels off the cutting edge. This will leave a smooth finish on the wood. The next type of gouge in the group is the spindle gouge. This is often called a detailing gouge. It is smaller in section than the roughing gouge and has a shallower flute. It is very sensitive in use and is used to refine between centre work by cutting beads, coves and other shapes. Spindle gouges are ground differently to the roughing gouge. This one has a fingernail profile on the cutting end, which means that the wings are ground back a little way down the blade. Spindle gouges may or may not be supplied with this profile already. It is widely recommended that spindle gouges are ground this way as it is more versatile to use. This grind is achieved by rotating the gouge on the grinding platform, and as the blade is rotated, swinging the handle in the direction of rotation. Getting the combination of rotation and swing correct each time takes a lot of practice. The easiest method is to use a fingernail profiler. This is a jig that is specifically designed to create and replicate this type of grind with ease. It features a base into which a boss is held on a movable rod. Into this can be fitted the swinging arm. The gouge is placed in the head, and the amount the gouge projects is then adjusted until the bevel is in full contact with the wheel. The bevel angle on the gouge in this instance is 35 degrees. The gouge is then locked in position using the central screw and levelling boss. The gouge is then placed against the revolving wheel and rolled, maintaining full bevel contact to ensure all the edges sharpened. The The jig sorts out the amount of rotation to swing automatically to produce a perfect fingernail profile with a single facetless bevel. A similar system is used on the wet grinding setup. When the tool is sharp, we can proceed with detailing the cylinder. We can start by creating a cove. A cove is a semicircular profile below the surface of the wood. Here is a diagram to illustrate this shape and the direction of cuts required to cut downhill. A cove is produced by having the gouge on its side with the bevel rubbing, and we make a scooping cut in the wood. So let's look at this carefully. The rest needs to be parallel with the cylinder and set just above centre. Start the lathe up to 1800 RPM and place the gouge on the rest with the flute vertical. Rub the heel of the bevel on the wood, raise the handle until the edge starts to cut, roll the tool into the wood in a scooping manner. As the cut progresses, rotate the gouge. We can only cut one side of the cove to the bottom, or we end up cutting uphill. So we widen and deepen the cove in stages. The procedure for cutting the other side of the cove is the same apart from the flute pointing in the other direction. Make a series of coves of different sizes to practice these cuts, leaving different sized gaps between each one. Remember to enlarge the cove in stages by cutting downhill from both sides. Notice how the shavings are peeling off the lower wing of the tool and not off the tip. In effect, the wood is being peeled off. To become proficient with any of the techniques shown in this video, we need to practice. The aim is to produce a nice, even sweep. With practice, the cutting actions become second nature, and as our confidence grows, we become more fluid in our movements. Once the wood has a series of coves on it, we can proceed to cut beads. These are semicircular patterns above the surface of the wood. The profile and the direction of cuts are shown clearly in these diagrams. To create these, we reverse the procedure for cutting coves. The gouge starts off horizontal and is rolled over to one side with the flute ending up vertical at the bottom of the cut. To ensure we always cut downhill, the other side of the bead is cut with the positions of the gouge reversed. As the bead intersects the cove, we can cut a fillet. This defines the parameters of the bead and cove. A fillet is simply an intersection point between the two profiles to set them apart. Practice cutting beads and fillets on the rest of the wood. Because we created different sized gaps between the coves, The beads and fillets will be different sizes. This is good practice to develop our skills. Once again, we're cutting with the bottom wing of the tool and not the point. Remember that the bevel rubs throughout the cut. The end result is a collection of nicely defined shapes. The crispness of the profiles is one of the things that sets hand turning apart from machine turned work. The next gouge in the group is the bowl gouge. Bowl gouges are used on faceplate work. It is thicker in section than a spindle gouge and has a deeper flute, which allows a wider range of cuts to be made due to the longer cutting edge. The bevel angle is 45 degrees. To sharpen it, it is placed flat on the grinding rest and sharpened by rotating the cutting edge on the revolving wheel. We use a similar resting platform when we sharpen with the wet grinder. The sharpening method is exactly the same. To demonstrate the bowl gouge, we need a blank of wood. This is pear and is 9 inches in diameter and 1.5 inches thick. Note the grain is running across the axis of the bed bars. This is fixed onto the worm screw held in a chuck. To have unimpeded access to the bowl, we can swivel this headstock round. Move the rest until it runs parallel with the face of the disc and adjust the height until it is just below centre. Revolve the disc by hand to see if anything fouls it. Before we start turning, let's look at a diagram that shows the direction of cuts to ensure that we cut downhill. Start the lathe up to 800 RPM. Place the gouge on the rest about ½ an inch back from the edge of the disc with the flute pointing towards the outer edge. Push the gouge forward. As it touches the wood, the bevel is not rubbing. As the tip enters the wood, the bevel begins to rub. This is a straight cut. To create a curved cut, rub the heel of the bevel on the wood, raise the handle until the edge starts to cut, and push forward, swinging the arm as the cut progresses across the wood. Repeat this process a few times to practice this cut. A coarse, aggressive cut is made by having the flute near the horizontal. A more refined cut is made by rotating the gouge a little more until we cut on the centre part of the lower wing. Remember, the flute still points in the direction of travel. There is a dramatic difference in the surface finish between the two cuts. We are now going to use the gouge to create an internal curved surface. Have the rest set as close to the work as possible and adjusted so it is just below centre. Position the gouge on the rest about 1 inch away from the centre. The flute points in the direction of travel, so in this instance it is pointing towards the centre of the bowl. The gouge is pushed in towards the centre with the cut occurring on the lower wing. A series of cuts are made working our way backwards towards the outer edge, deepening the hollow as we go. All of the cuts are made cutting downhill. The bevel is rubbing throughout these cuts. When we near the outer edge, it will be necessary to measure the thickness of the bowl wall. To do this, we make use of calipers. These calipers are double-ended. When we take a measurement, we can see how thick it is, as the gap on the other end is exactly the same size as the part being measured. These come in a variety of shapes and sizes to suit different projects. This covers the basic principles for using gougers. We are now in a position to look at the next category of tools, which are skew chisels. These chisels have an angled or skewed cutting edge, hence their name. There are standard skews and oval skews. The only difference is the shape of the blade. Both are used in exactly the same way and in effect are the planes of the spindle turner's toolkit. They can be used to smooth the wood, clean up the end grain, make V-cuts and beads. The beginner to wood turning often finds the oval section tool easier to manipulate, so this is the style we will be using for this video. A skew has two bevels which are ground to form an angle of 30 degrees. The tool has a toe, which is the long tip, and a heel, which is the shorter point. These are the extreme ends of the cutting edge. It is a fine cutting tool, so it is important that it is sharpened correctly. When using the bench grinder, a stable platform is vital to rest the blade on. Once the rest has been adjusted to the correct angle, the cutting edge is offered up against the revolving wheel and traversed across the face. The oval section means that the blade can rock, so a good hold and a positive movement are necessary to achieve a good facetless bevel. Once one side is sharpened, reverse the procedure and do the other bevel. The wet grinder utilises a special holding jig for the skew. In addition to this, there is also an angle finder which can be set to suit the diameter of the wheel and the sharpening angle required. When the angle is found, the tool is then sharpened. Both sides need to be sharpened to produce a keen edge. A finer edge is gained by honing the bevels using the leather-faced wheel on which is a microfine abrasive. Once sharp, we are in a position to use the skew on this cylinder of maple. We are going to use the skew to plane the wood into a smooth cylinder. Adjust the rest so that it is parallel with the cylinder and about ½ inch below the top. Place the skew onto the wood with the toe uppermost and the bevel rubbing. Rotate the wood by hand. Raise the handle until the edge starts to cut the wood at a 45-degree angle. Note that the cutting should occur in the lower half of the edge. If cutting occurs above the centre of the edge, the central balance of the tool could shift. This will cause the edge to take a thicker cut than we can control, which in turn will result in the tool spiralling backwards. In reality, this happens at a much faster speed than this, so be careful and always cut with the lower half of the edge. We can now practice what we've just learnt. Start the lathe up to approximately 1600 RPM. Start the cut in a bit from the far edge of the cylinder, get the bevel rubbing, raise the handle until it starts to cut and then move it across the wood. The thickness of cut is altered by raising or lowering the handle. Take 2 or 3 passes to create a uniform surface finish. Remember, the bevel must be rubbing during the cut. The dust on the blade clearly shows that cutting has been occurring in the lower half of the edge. After these cuts, go back and smooth the area we left earlier. All we have to do is turn over the skew and work in the other direction. As you can see throughout all of these smoothing cuts, we are always cutting downhill. Take as many passes as necessary to create a uniform cylinder. These are very controlled cuts, where the shavings just peel off the cutting edge. These cuts have left a very fine finish on the wood. We're going to use the toe of the skew to clean up the end of this cylinder. Adjust the tool rest so it is parallel with the cylinder and just below centre. For this cut we still have the bevel rubbing, but not the whole bevel face. Instead we use the area marked green only. If the whole bevel rubbed, all of the cutting edge would have permission to cut. This would be too aggressive and would result in a catch. Instead we want to limit the cut and sever the fibres cleanly. To do this, the tool must have a slight incline off vertical, leaning away from the end grain as it slices through the fibres. The cut will not run horizontally through the wood, but will instead arc through towards the centre. With the lathe running at 1800 RPM, place the skew vertically on the tool rest. Keep the handle low and push the toe into the revolving wood about a 1/16 of an inch away from the end. The skew is now cutting. Incline the tool about 5 degrees off vertical and push forward, raising the handle during the cut so the tip arcs down towards the centre. The angle here is exaggerated to illustrate this technique clearly. There is no torn end grain from this cut. The toe of the skew can also be used to cut a V in the wood. The technique for this is primarily the same as that used to cut the end grain. The handle is held low with the cutting edge vertical, and we arc into the wood by raising the handle to make the initial cut. We need to take cuts from both sides to make the V wider and deeper. Remember how we worked from both sides in the cove? This is the same to ensure we cut downhill. Small, light cuts are made from both sides until the required depth is reached. The depth needs to be about 5/8 of an inch for this V. Make another V cut, the same size, about 1 inch away. Remember, throughout these cuts the bevel is rubbing, but only the extreme end near the toe. The walls of the V's are cleanly cut, and the profiles are neatly defined. Once the V profiles are cut, we can use the skew to cut a bead. Bring in the rest and adjust it so that it is parallel with the work, and set just above centre. For this we're going to use the heel of the tool and work the heel the same way as the toe, but instead starting off horizontal. We start from the top of the bead and roll the tool down. To make the cut, start the lathe up to 1800 RPM, place the blade on the rest and have the bevel rubbing. Raise the handle until the short point starts to cut. Roll the blade over to form the side of the bead, remembering that the bevel rubs throughout the cut. The tool is cutting at the very tip of the heel. We reverse the tool and repeat these cuts to form the other side of the bead. It is worthwhile practicing these cuts with the skew, as there is no tool that will create a finer finish in spindle work than this. The next group of tools to look at are parting tools. There are various parting tools available, and they all vary in shape and size. Their primary function is to separate or part off the project from the waste wood, whether it be spindle or bowl work. They can also be used to create the spigots that hold a project in a chuck. For this video we will be using a 1/8 inch standard parting tool. Parting tools are a type of chisel. Each has two bevels that intersect to create a narrow cutting edge. Sharpening is very easy. Set the rest to the required angle. The bevels in this instance form a cutting edge of 30 degrees. Place the blade vertically on the rest and move the cutting edge across the face of the wheel. Both sides need to be sharpened to form an effective cutting edge. A single facetless bevel is still the required end result. The water-cooled grinder makes use of a jig to hold the parting tool to ensure the angles are correct. It is then traversed across the wheel to form the cutting edge. This tool, as with any other, needs to be sharp to work efficiently. Let's look at how to make a parting cut. The width of the cutting edge on the end of this maple cylinder. The tool rest should be parallel with the spindle and set just below centre. Start the lathe up to 1500 RPM. Place the parting tool vertically on the rest, keeping the handle low. Position the heel of the bevel on the wood and raise the handle until the tool starts to cut. Arc through the wood until we reach 1/4 of an inch from the centre. The bevel rubs throughout this cut. If we parted off through the wood, the project would be unsupported and fly off the lathe. This shows the action of the parting cut, so let's try this cut in the middle of the wood. The tool is used in the vertical plane much the same way as the skew was to clean up the end grain. The only difference being the tool should have no incline when parting through the wood. The parting tool, when used in the solid section of wood, may bind or jam as it cuts. To stop this from happening, remove the parting tool and make a small cut next to the main one to widen the gap. Remember not to part all the way through or the wood will fly off the lathe. The parting tool can also be used to create spigots for holding in a chuck. To make one, take a parting cut the width of the cutting edge on the end of the cylinder. We part down a small distance and measure with calipers to see how much extra needs to come off. Continue to measure at intervals until the correct dimension is achieved. There needs to be about 1/4 of an inch of spigot for the jaws to grip onto. To this end we need to make another cut 1/8 of an inch wide. Once completed, angle the parting tool to create the dovetail. We cut with the lower corner of the edge to create the dovetail shape. The bevel is still rubbing during this cut. This can now be fitted into the chuck. This covers the principles of using the parting tool, so we can move on to the last of the 4 tool groups, which is scrapers. These are finishing tools. There are many variants to suit different shaped projects. Their function is to clean up the work after the initial profiling has been completed. They are mainly used on the end grain of spindle work and to finish bowls and platters. Irrespective of the end profile on the tool, they have a single bevel that intersects with the flat face to form the cutting edge. The recommended sharpening angle for scrapers is 80 degrees. Sharpening is once again carried out using the platform on the bench grinder. There is not an 80-degree setting on the platform, so we can use a finger underneath the tool to support it. A platform is also used when sharpening scrapers on the wet grinding system. The blade is positioned flat on the platform and then manipulated on the wheel to create a sharp edge. The tool relies on a fine burr on the cutting edge to sever the fibres of the wood. A burr is a fine wire edge created when sharpening. If we run our fingers across the edge, we can feel it. The main difference between these tools and the other 3 groups is that these are not used with the bevel rubbing during the cut. Instead, they are placed on the tool rest and presented up to the work in a trailing manner. The outside of this bowl is ready for finishing. To create a ripple-free surface on the outside, we use the square end scraper. Position the rest just above centre and about ½ inch back from the face of the bowl. Set the lathe running at 1500 RPM, place the scraper flat on the rest and raise the handle until the tool trails by 10 degrees. Push the scraper forward and traverse it across the wood, cutting just below centre. Be gentle, too much pressure will cause it to take a large cut and jam in the wood. The bevel is not controlling the cut, it is controlled by the pressure we apply to the tool. Aggressive cuts can be made as well as fine cuts. Notice the thin shavings from the tool when a gentle cut is made. It is important that the blade be kept flat on the rest throughout the cut. A few passes may be necessary to achieve a smooth profile. The end result should be a surface without any torn grain. To finish the inside of the cup on this part-turned goblet, we will use the curved scraper. Because there are no corners on the cutting edge, it can be traversed across the concave surface safely. Adjust the rest until it is just above centre, and set the lathe running at 1800 RPM. The scraper is placed flat on the rest and trailed so it cuts on or just above centre. This applies to all concave surfaces if we are to ensure we cut downhill. With end grain work, we work from the centre out towards the edge. This will ensure that there is a longer fibre supporting the one being cut. Gentle passes are made to create a smooth surface. We have now explored the four main tool groups. In addition to the equipment we have just covered, we also require a few other things to create a well-finished piece of work. The first of these is abrasives. These are available in different grades. A good wood turning abrasive is aluminium oxide, which is bonded to a cloth back for flexibility. Ideally, it should also have an anti-clog coating. Cloth enables us to tear it when we need a smaller piece. A few grades are necessary. A good selection would be 100, 180, 240 and 320 grits. The 100 grit would enable us to tackle the most stubborn of torn grain, and from there work through to produce a fine finish with the 320 grit. These are used after the tools to refine the surface prior to applying a finish. Finishes are the next products we need. These are applied to the wood to protect it and to highlight the grain to its fullest potential. The finish applied will depend on the project. If a bowl is to be used for storing food, the finish should be non-staining, non-toxic and water resistant. If the project is decorative, then it needs to resist marking when handled by people and show the wood off to its full glory. There are two main groups, penetrative and surface finishes. The penetrative finishes are capable of soaking deep into the fibres of the wood and protecting it. This group includes oils. The most common oil finish for wood turning is Danish oil. This is an oil that penetrates and seals the wood, leaving a heat, water, acid and alkali resistant finish. We will use this later on a bowl. Surface finishes, as the name implies, do not penetrate the fibres of the wood very far. The group includes universal lacquer, friction polish and wax. For the two spindle projects we will undertake later, we will use friction polish. This is a special formulation of polish that is applied to the revolving work on the lathe. It will impart a high gloss to the work and can be handled without marking. It is mainly used on small decorative work. Before we can use the finishes, it is necessary to have something to apply the finishes onto the wood with. One of the best materials for this is wood turning finishing cloth. This is nice and thick and will tear rather than catch should it snag on the wood. This is a good safety factor. Let's use these materials and the skills we've learnt to create a few simple projects. The first of these is a weed pot or bud vase. Here is an example of one made from boxwood. It is the same style as the one we are going to make, and it is a spindlework project. The wood for this is maple, and it is 3 inch by 3 inch square and 6 inches long. Mount it between centres. and adjust the rest until it is as close to the work as possible without fouling it, and set just below centre. Start the lathe up to 800 RPM and turn the square stock around using a roughing gouge. Rub the heel, raise the handle until the edge starts to cut, and then move on with the flute pointing in the direction of travel. Reverse the gouge position to turn the other end of the square stock. The section of the blade in contact with the rest is directly in line and supporting the part of the edge cutting the wood. A few cuts will be necessary to make it fully round. Make a skimming cut to remove the fine ridges left by the initial cuts. The end result should be a nice smooth cylinder of wood. Once round, we cut a spigot so the wood can be held in a chuck. Speed the lathe up to 1500 RPM. Take a 1/8 inch parting tool and cut a spigot to suit the chuck jaws. Measure with calipers to make sure it is the correct size. To create the dovetail, we use the corner of the parting tool. Remove the wood and centres from the lathe and mount the wood in the chuck. Swivel the headstock if possible to allow full access to the work. Position the rest so it is just below centre. We need to profile the top of the vase first. For this, take a spindle gouge and make a small cut into the centre, remembering to rub the bevel. At the centre, swing the gouge round so it is in line with the centre and horizontal. Roll the blade over until the flute is almost vertical. Push the tool into the centre. When the lathe is rotating anti-clockwise, as with this one, the flute should be on the left-hand side. The gouge is now acting as a drill. Withdraw the gouge often to remove the waste wood. The smoke is due to friction between the tool and wood, so be careful as the blade will be hot. Drill to a depth of 4 inches. This is the hole for the dried flowers. With the gouge in the same position, draw the tool out towards the outer edge. This is not a bevel rubbing cut, but the wood is being cut with the lower wing of the tool. Remember, end grain has to be worked from the centre out to ensure we are cutting downhill. Make a few cuts until the whole top face has been smoothed and has a gentle curved profile. The top of the vase needs to be about 1.5 inches in diameter. So reduce the size slightly with a few push cuts diagonally across the edge of the cylinder using the spindle gouge. When we have a nice gentle curve on the top of the vase, the neck can be profiled. Use a roughing gouge to remove some of the bulk of the waste wood. Because the work extends quite away from the chuck, it is flexing slightly, hence the buzzing noise. So bring up the tailstock and revolving centre to support it. The buzzing has now stopped. The neck is created in the same way as a cove. Using a spindle gouge, take a series of scooping cuts practiced earlier until we have an evenly curved neck. Only cut to the bottom of the cove, not uphill. But be careful, do not cut too deep as there is a hole in the centre of the wood. The cutting always occurs on the lower wing of the flute. Once the neck is profiled, we can shape the body. This is cut in the same manner as a bead. Start at the top and roll down, blending the main body in with the cove. The bevel rubs throughout the cut. A nice flowing transition is required. To shape the bottom section, use the roughing gouge once again to remove some of the waste timber, remembering to cut downhill. The roughing gouge is very effective at removing wood quickly. We can then use a spindle gouge to refine the shape further by rolling down from the top of the body towards the chuck. A few cuts will be needed to form it properly. We now need to make the base of the vase. Do not make the base too small or the vase will be prone to topple over. A good guide is to make the base of a bowl or vase between 1/3 and 1/2 of the overall width of the project. A little detail can be put around the neck of the vase with a parting tool. Gently touch the corner of the cutting edge onto the wood. Add a couple more V-cuts if desired. Now that the neck is detailed, remove the tailstock and banjo. Take a piece of 180 grit abrasive and sand the project. Don't forget to use dust protection and extraction. By removing the banjo and tailstock, we have free access to the work. After the 180 grit, use the 240 to remove the scratches left by the coarser abrasive. The work is sanded from the underside. If the abrasive catches, it is thrown away from us. If we sand from the top and the abrasive catches, our fingers would also catch and get thrown downwards. After the 240 grit, use the 320 grit. A tip when sanding is to keep moving the abrasive. If we keep it stationary, deep scores will be cut into the wood which would be difficult to remove. When evenly sanded, take the friction polish and shake vigorously. This ensures that the contents are mixed and dissolved nicely. Put some friction polish onto the cloth and apply it to the work. When completely covered, put some more polish onto the cloth and switch on the lathe to 2000 RPM. Apply the cloth to the revolving project and work it across the surface, gradually increasing the pressure as it is manipulated across the work. This is how the high gloss finish is built up. When fully polished, position the rest just below centre and with a parting tool separate the work off from the waste. Do not cut all the way through or the vase will fall off. Leave about a 1/4 inch pip in the middle. Saw through the pip to remove the vase from the lathe and sand and polish the bottom. The vase is now ready for display and use. The next project we're going to tackle is a goblet. Once again, this is a spindle project and it is a little more advanced than the vase. Don't worry, we have already practiced all of the cuts necessary for this project. To make the goblet, we need a 2.5 inch by 2.5 inch square by 6 inch long piece of wood which is mounted centrally between centres. The drive spur is held in the chuck. The wood shown is cherry. Adjust the rest until it is just below centre and a 1/4 inch away from the face of the wood. Rotate the wood by hand to ensure it doesn't foul the rest. Start the lathe up to 1000 RPM and with the roughing gouge make the square into a cylinder. Place the blade on the rest, rub the heel of the bevel and raise the handle until the edge starts to cut. And then traverse the gouge across the face of the wood. Make as many passes as is necessary to make the wood fully round. The bevel rubs throughout all of these cuts. Once round, smooth the cylinder across the top using the skew chisel with the lathe running at 1800 RPM. Remember, when planing with the skew, the rest should be half an inch below the top of the cylinder, and we cut with the lower half of the edge. Reverse the direction of the skew to clean up the section nearest the chuck. A smooth, ripple-free surface is required. When smooth, cut a spigot with the parting tool so we can hold it in the chuck. Use calipers to make sure the spigot's the correct size. And 2 cuts may be necessary so that the spigot is large enough for the jaws to hold on to. When the spigot is complete, mount the work into the chuck. There is a large overhang from the chuck, so bring the tailstock in for support. Adjust the tool rest until it is just below centre. And with a spindle gouge, part profile the external cup of the goblet. Cut downhill with the flute pointing in the direction of travel. The cup is profiled in the same way as a bead. Start with the flute horizontal and the heel rubbing the work. Raise the handle until the edge starts to cut. Then roll the gouge over to the side. When we work on a goblet, we have to work from the extreme end of the work back towards the chuck. If we work in the other direction, the stem could not support the cutting of the goblet cup and so snap. Repeat this cut a few times to get the required shape. The external profile must be close to the required shape, as we will hollow out the inside to match this form. Once we are happy with the outside profile, stop the lathe, remove the tailstock and adjust the rest so that it is parallel with the end of the work and just below centre. To shape the inside of the cup, we need to make the plunge cut practiced earlier in the end of the wood. Only this time we plunge in a little and then scoop out the wood using the lower wing of the cutting edge. We continue and make as many cuts as necessary to match the internal profile to that of the external shape. This technique is a safe and effective method for removing end grain. The thickness of cut is controlled by the pressure we apply to the tool. Best results are achieved by using a uniform pressure and rate of travel. The shavings peel off the cutting edge on the lower wing. To clean up the surface, we can use the curved scraper. Set the rest just above centre, bring in the scraper and rest it flat on the rest. Trail the blade by 5 to 10 degrees and starting from the centre take a delicate cut out towards the outer edge. Cut on or just above centre throughout. The cup is getting thin now, so the cuts must be gentle to minimize vibration. Take a fine skimming cut on the outside to finish the lip of the goblet. When we have a smooth transition between the inside and outside, sand the inside of the cup until smooth. Remember the dust protection. Once sanded to a fine finish, use friction polish to seal the wood. If the inside was left until the last thing, the stem would flex and we could not finish it properly. Having completed the inside, the external face of the cup can now be finished. Use the spindle gouge to take delicate refining cuts. We are always cutting downhill, and the bevel is rubbing throughout the cut. The cup wall thickness should end up about 1/8 of an inch thick. There needs to be a transition between the cup and the stem, so at this point we create a little fillet to highlight this transition. Once we are satisfied with the profile of the cup, sand it. Remember the dust protection. Work through the grades until we're left with a silky smooth finish. After sanding, apply the friction polish. To achieve a uniform high gloss finish on the project, even pressure needs to be applied when buffing the work. Now the cup is complete, we need to profile the stem. However, the stem will become very thin and may flex when shaping it. To stop any movement, pack some cloth into the cup of the goblet and bring up the tailstock fitted with a revolving centre to stabilise it. The cloth prevents the revolving centre marking the finished surface. Set the lathe to run at about 1800 RPM and use a roughing gouge to remove the bulk of the stem waste wood, remembering to cut downhill. Once the bulk of the waste is removed, profile the stem with a spindle gouge. The lathe should be running at about 2000 RPM. The cuts are the same as those used to turn a cove. Start from the cup and work back towards the chuck. The cutting always occurs on the lower wing of the tool. The skew can be used to refine where the stem meets the base with V-cuts to create a fillet. For these cuts we use the toe of the skew. To make the V-cuts, have the handle low, raise the handle until the toe starts to cut and arc into the wood. Once this intersection has been defined, create the bottom sweep with the spindle gouge. It is easy to see why the spindle gouge is called a detailing gouge. The stem is getting quite thin, so very delicate cuts are necessary. Smooth the middle section of the stem with a skew. Once the stem is profiled, create the foot. We require a nice gentle curved face which meets with the fillet on the stem. Partially part off the goblet to a depth of 1 inch. And make a relief cut to prevent the tool from binding. Move the tool rest out of the way and then sand and polish the rest of the goblet. When sanding, be careful not to round over the crisp edges left by the tool on the fillets. When polished, part through the rest of the wood, but leave a 1/4 inch pip in the middle. Remove the tailstock and saw off the goblet. Clean off, sand and polish the bottom. We now have a beautiful cherry goblet. The next project we're going to undertake is a bowl. This one is made from acacia. We are going to make one the same shape but out of sycamore. This is a faceplate project, so the grain runs across the axis of the lathe bed. First of all, select a disc of wood 8 inches in diameter and 3 inches thick. Find and mark the centre using the centre finder. We're going to use the screw chuck set up with a worm screw, so drill an appropriate size pilot hole to suit the screw to the required depth. A good tip is to use a felt marker and mark the drill at the correct depth to suit the screw. Once the blank is drilled, mount it on the screw on the lathe. We're going to shape the outside of the bowl first. If possible, swivel the headstock to ensure unimpeded access to the blank. Adjust the tool rest until it is just below centre, and rotate the wood by hand to ensure that it does not foul the rest. When all is correct, start the lathe up to 1000 RPM. We will use a bowl gouge to profile the bowl. Place the blade on the rest, rub the bevel, raise the handle until the edge starts to cut and then push working towards the outer edge. By working from the middle of the blank towards the outer edge, we are cutting downhill. The flute points in the direction of travel and the cut is made with the midsection of the lower wing. Make a series of these cuts. There is no need to make the disc perfectly circular before the main profiling occurs. As the cuts progress, the disc will be profiled and the irregularities of the edge will gradually be removed as the shape develops. We're now in a position to start refining the shape of the bowl. Start a cut further back on the face. This time, as the cut progresses, swing the handle to cut a curved face. The amount of swing will affect the radius of the curve. We require a gentle sweep. Carry on with the cuts until we are within 3 inches of the centre of the bowl, and the blank is fully round. Since we are shaping the underside of the bowl at the moment, we will eventually need to turn it over and shape the inside. To do that, we need to hold it. To that end, we will cut a spigot to fit in a chuck. Take a pair of calipers that are set up to the correct diameter for the jaws and lay these on the face of the bowl and gauge how big the spigot needs to be. The spigot is not only where we hold the bowl, it will also be the foot on which the bowl stands. For the bowl to be stable when turned, it needs to be about a third of the overall diameter. Take the parting tool and plunge cut into the face of the bowl to a depth of 1/4 of an inch, making sure that the spigot left is oversized. Once cut, turn away some of the bowl until we create a profile that causes the spigot to stand clear of the main body. The bowl gouge cannot cut properly near the spigot, so we have to cut against the grain. This is contrary to the rule of cutting. However, if gentle cuts are made, the surface damage, although noticeable, should not be too deep. Take a cut across the face of the spigot to create a curve. This will ensure the spigot sits square in the jaws without rocking. When the spigot is proud of the face, measure it again so it can be trimmed to the correct size. For this we use the parting tool. Adjust the size of the spigot by paring down the sides and at the same time create the dovetail profile that the jaws grip onto. When the spigot's the correct size, profile the rest of the bowl with the bowl gouge to the required shape. Once happy with the overall shape, use a square-end scraper to remove any of the fine ripples in the surface. Don't forget the scraper is used in a trailing manner and cuts just below centre on external profiles. Very gentle pressure is required to get these delicate shavings. A friend in America once said, "They're as fine as frog's hair." A few cuts may be necessary. The bowl is now ready for sanding. Scraping has left a very good finish on the surface of the bowl, so we can start off with quite a fine abrasive, for example 180 grit. Don't forget the dust extraction. When sanding, remember to keep the hand moving to minimise the radial scratches. Use successively finer abrasive to improve the surface finish. After sanding, we can apply a finish to the bowl. We're going to use Danish oil, which is water, heat, acid and alkali resistant. Apply some oil to the stationary work using a polishing cloth. Make sure that the whole surface is well covered. Once covered, apply a little more oil to the polishing cloth and start the lathe up to 1500 RPM. Work the oily cloth across the surface of the bowl. This will buff it up to a nice satin sheen. Satin is the term used to describe a luster that is in between gloss and matte. Once fully polished on the outside, we can take the bowl off the screw and mount it in the chuck on the spigot once the screw has been removed. Make sure the bowl is fully secured. Align the rest so that it is parallel with the face of the bowl and set it just below centre. Start the lathe up to 1500 RPM. Place the blade of the bowl gouge on the rest, rub the bevel, raise the handle until the edge starts to cut and then push forward into the centre of the bowl, with the flute pointing in the direction of travel and the cutting occurring in the middle section of the lower wing of the tool. Make a series of cuts working back towards the rim. The internal face is curved, so the handle is swung towards us in order to create the curved face. The blade is arced up into the curvature of the bowl and then brought back down into the centre. This is a very effective cutting method. When we near the rim, check the wall thickness with a pair of calipers to see if it is even. In this instance it is thicker at the bottom, so we can take a delicate skimming cut or two to refine the shape until the wall is a uniform thickness. A final finishing cut can be made with a curved scraper. On internal curves, the cut is made on or just above centre. Once the shape has been refined with the scraper, sand the project until smooth. When sanding a bowl, work between the 6 o'clock and 9 o'clock positions. This is known as the safe zone. If the abrasive or cloth catches, it is thrown away from us. If we were to sand anywhere else, the fingers could get drawn into the surface of the bowl and spun out again with some force. Apply Danish oil to the project when stationary with the finishing cloth. Finish off by buffing the bowl with an oily finishing cloth to create that satin sheen. We can now remove the bowl from the lathe. The end result is a nicely proportioned bowl with an even wall thickness. This concludes the last of the projects. In this video we have covered the topics of wood and how we select it, and the faults to look out for, the lathe and its components, fitments that hold the work, the tools required for turning and how they are used and sharpened, finishes, and finally practicing the techniques on a bud vase, goblet and bowl. When we were turning, we followed guidelines which ensured we turned safely. Let's recap on these. The section of the blade in contact with the tool rest should be directly in line with and supporting the part of the edge cutting the wood. All tools except scrapers cut with the bevel rubbing. Always cut downhill to achieve the smoothest finish possible from the tool. Keep the rest as close to the work as possible when turning to prevent the tool from being levered down. Match the speeds of the lathe to the size of work being turned. The larger the project, the slower the speed should be. Protect your eyes and lungs with good quality safety equipment. All of these techniques and principles in this video are designed to be foundation blocks from which we can develop and refine our skills further through practice and patience. The realms of wood turning are vast and diverse and will fascinate and challenge for many years to come. The main thing to remember when exploring these various avenues is to have fun. The tools and lathes shown in this video are manufactured by Robert Sorby of Sheffield, England, the world's premier manufacturer of wood turning tools. All Robert Sorby tools are available from recognised woodworking tool dealers around the world. For more information, contact us at the address shown or visit our website, which regularly gives updated information on dealers, new products and our highly popular demonstrations.